overproduction. Final simple English trainer speech. Main source, final PPTX slide order and slide numbers. Format, slide number, slide title plus readable trainer speech. Use this document while presenting online. The text is written in simple spoken English and is designed to be read aloud. Opening, before slide 48. Use only at the beginning of the first online session. Good morning, everyone, and welcome to our online training program on the 8 wastes in public transport. My name is Bari Zogaz. I am a Lean Management, Six Sigma, TPM, and Management Systems consultant and trainer. I have more than 25 years of professional experience in operational excellence, process improvement, data analysis, and Lean Six Sigma applications. During this program, our focus will be very practical. We will not only talk about Lean concepts. We will also discuss how these wastes appear in real public transport operations. Each day, we will start at 11 o'clock Turkey time and finish around 13:30. In the full training structure, this section is day 3. For our online program, this is our first session, and we begin with the first operational waste, overproduction. My aim is to make the sessions interactive and useful for your daily work. Please feel free to share examples from your own operation, ask questions, and discuss openly. Now, let us begin with today's topic, overproduction. Slide 48, overproduction. Day 3 opening slide and learning objective. Today, we start with overproduction. Overproduction is the first waste we will discuss in detail. In manufacturing, it means producing more than the customer needs. In public transport, the same idea exists, but it looks different. Here, overproduction can mean running too many buses, too many trips, or too much capacity compared with real passenger demand. At first, this may look like good service. But Lean asks a different question. Does this extra service really create value for passengers? During this session, we will look at the definition, examples, causes, impacts, and possible solutions. We will also discuss how data, DRT, ITS, and route optimization can help us match service supply with real demand. The main idea for today is simple. More service does not always mean more value. The right service at the right time for the right demand creates value. Slide 49. What is overproduction? Definition in simple public transport language. Let us begin with the basic question. What is overproduction? In simple terms, overproduction means producing more, earlier, or faster than required. In public transport, we are not producing physical products. Our product is transport service. Every bus trip, every tram service, every train departure consumes resources. So, if we run more vehicles or more services than actual demand requires, we may be creating overproduction. For example, an almost empty bus running again and again during off-peak hours may look like availability. But if there is no real passenger demand, it also means fuel, driver time, maintenance, and budget are being consumed without enough value. Please remember this sentence. More service does not always create more value. Now I would like to ask you a simple question. Have you ever seen empty buses or trams running in the middle of the day? If yes, what do you think caused that situation? Slide 50. Definition and principle. Lean principle. Service should follow real passenger demand. Lean defines overproduction as any output that exceeds the customer's immediate need. For public transport, the customer is the passenger. So we can translate this definition into a very simple idea. If actual demand is lower than service supplied, there is potential waste. This does not mean we should reduce all services. Public transport also has social responsibilities. We need accessibility, safety, and reliability. But Lean asks us to make decisions with evidence. Service supply should follow demand patterns, not only historical habits or tradition. A good way to think about this is the pull principle. Passenger demand should pull service supply. If we only push services into the network without understanding demand, we may increase cost without improving passenger value. So the key question is, does this service level match real passenger need? Slide 51. Historical reason. Why overproduction can continue for years. Overproduction often has historical reasons. Many operators continue to plan capacity based on old routes, old habits, political expectations, or prestige reasons. Sometimes a route continues because it has always existed. Sometimes service levels remain high because reducing them may look politically difficult. This is understandable. Public transport is a public service, and decisions are not only technical. There are social, political, and accessibility factors. But from a lean perspective, we should still ask, is this service supported by current data? A route may have been useful 10 years ago, but the city may have changed. Passenger demand may have changed. Workplaces, schools, shopping areas, and travel patterns may be different today. If we do not review the service with data, historical decisions can slowly become overproduction. I would like you to think about your own system. Where do we operate service because we always have, not because the data clearly supports it? Slide 52. Quantifying overproduction. Using KPIs to detect overproduction. Now we come to measurement. Lean and Six Sigma both depend on data. If we want to improve overproduction, first we need to detect it. This slide shows 3 useful KPIs: average load factor, vehicle kilometers per passenger kilometer, and cost per rider. Average load factor tells us how full the vehicle is. A simple formula is passengers divided by available seats multiplied by 100. For example, if a bus has 80 seats and only 20 passengers, the occupancy is 25%. If this happens once, it may be normal. But if it happens every day at the same time on the same route, it may show overproduction. Vehicle kilometers per passenger kilometer also helps us understand how much movement is needed to create actual passenger travel. Cost per rider is another important indicator. If we spend a lot of money but serve very few passengers, we need to investigate why. The purpose of these KPIs is not to punish anyone. The purpose is to make the waste visible and support better decisions. Slide 53. Causes of overproduction. Main causes in public transport systems. Now let us look at the causes of overproduction. The first cause is lack of real-time demand data. If we do not know when and where passengers actually travel, we may plan based on assumptions. The second cause is rigid timetables. Many timetables are difficult to change, even when demand changes. This creates a gap between real need and planned supply. The third cause is political pressure to add more buses. In many places, more buses are seen as better service. But without demand analysis, more buses can also mean more waste. The fourth cause is poor communication between planning and operations. Planners may create schedules, but drivers and operations teams see the real daily situation. If these teams do not communicate well, overproduction can continue. Let us think about your own organizations. Which cause is the most relevant for you? Lack of data, rigid timetables, political pressure, or communication gaps? This is important because the solution depends on the real cause. Slide 54. Impact on operations. Operational consequences of overproduction. Overproduction has a clear impact on operations. When we run more service than needed, we use more fuel or energy. We need more driver time. We increase maintenance needs. We also put more kilometers on the vehicles. At first, one extra bus may not look like a big issue. But when this happens every day, across many routes, the total cost becomes very large. There is also an opportunity cost. If money is spent on unnecessary service, that same money cannot be used for maintenance, passenger information, accessibility, digital tools, or service quality improvements. So overproduction does not only create direct cost. It also takes resources away from areas where passengers may receive more value. In lean thinking, we should always ask, are we using our resources in the best possible way to create passenger value? Slide 55. Environmental impact. Environmental consequences of unnecessary mileage. Overproduction also has an environmental impact. Every unnecessary kilometer creates energy consumption. If the vehicle uses diesel, it creates emissions. If the vehicle is electric, it still uses electricity and battery life. Unneeded mileage also creates noise, tire wear, brake wear, and additional maintenance demand. So, overproduction is not only a cost problem, it is also a sustainability problem. Let us imagine a simple example. If a network has 10% more service than real demand requires, that extra service creates unnecessary fuel or energy use every day. Over 1 year, this can become a very large environmental burden. For public transport organizations, sustainability is not only about buying cleaner vehicles. It is also about using the existing service wisely. Efficient planning supports both financial performance and environmental performance. Slide 56. Passenger Experience Effect. Why more buses can still create per service. Now let us look at the passenger experience. There is an interesting paradox. More buses do not always mean better service. If buses are too frequent without proper coordination, they may bunch together. Passengers may wait a long time, then two buses arrive almost at the same time. From the passenger point of view, this feels unreliable. So the issue is not only how many buses we operate. The issue is how stable, predictable, and useful the service is. This connects to Six Sigma thinking. Variation in service intervals can become a service defect. Even if the average frequency looks good, the passenger may still experience long waiting times. For passengers, value means reliable arrival, clear information, safety, comfort, and reasonable waiting time. Therefore, overproduction can sometimes hide poor service design. More vehicles may cover the problem for a short time, but they do not always solve the root cause. Slide 57. Economic Analysis. Simple financial logic of overproduction. Let us make the financial impact more concrete. Savings from reducing overproduction can come from fuel, labor, maintenance, and depreciation. Imagine that one bus costs 100 euros per hour to operate. Now imagine that 10 extra buses run 5 unnecessary hours per day. That is 10 buses times 5 hours times 100 euros. This means 5,000 euros of waste in one day. If this continues for 20 working days, the monthly waste becomes 100,000 euros. Of course, this is a simple example. Real numbers will be different in every organization. But the logic is clear. Small daily inefficiencies become very large annual costs. This is why overproduction should not be seen as a minor scheduling issue. It is a strategic cost issue. When we reduce unnecessary service while protecting accessibility, we free resources for real improvement. Slide 58. Demand-Responsive Transport, DRT. Smart matching of supply and demand. One modern solution is demand-responsive transport, or DRT. DRT means matching service supply more closely with real demand. Instead of running the same fixed service all the time, vehicles can be assigned based on booking data, passenger requests, or demand patterns. This can be useful especially in low-demand areas, off-peak hours, or flexible service zones. The important point is this: lean does not mean cutting service. Lean means serving smartly. If a fixed bus route runs almost empty for many hours, a demand-responsive model may provide better value. It may protect accessibility while reducing unnecessary kilometers. Of course, DRT is not the right answer for every route. High-demand corridors still need strong fixed service. But for some areas, DRT can be an important tool against overproduction. The key is to use data and choose the right service model for the right demand pattern. Slide 59. Role of ITS and data analytics. Using data to adjust service frequency. Another important solution is ITS and data analytics. Intelligent transport systems collect data from many sources: GPS, ticketing systems, passenger counters, sensors, mobile applications, and operational dashboards. This data helps us understand ridership, speed, dwell time, punctuality, and route performance. Without data, we may only guess. With data, we can see where demand is high, where it is low, where buses are delayed, and where capacity is not used. Data analytics can help planners adjust service frequency, redesign routes, and identify overproduction more accurately. But data alone is not enough. Management must also respond to the data. If we collect data but do not use it in decisions, the waste remains. So the real question is, what data do we already have, and how can we use it better? Slide 60. Simple lean tools for detection. Practical tools to see overproduction. This slide introduces 3 simple lean tools for detecting overproduction: value stream mapping, takt time analysis, and Pareto charts. Value stream mapping helps us see the full flow of a service process and separate value-adding and non-value-adding activities. Takt time analysis helps us compare the pace of demand with the pace of service supply. In simple words, it asks whether our service rhythm matches passenger demand. Pareto charts help us focus on the biggest problems first. Maybe a small number of routes create most of the low occupancy kilometers. If we find those routes, we can start improvement where the impact is highest. We do not need to make this too technical at the beginning. The first step is visual clarity. Where is service supplied? Where is demand? And where is the mismatch? Lean tools help us see what is normally hidden in daily operations. Slide 61. Preventive approaches. How to prevent overproduction before it grows. Now let us discuss preventive approaches. First, planning should be based on demand segments, not only politics or tradition. Peak hours, off-peak hours, weekends, special events, and low-density areas may need different service designs. Second, pilot lines are useful before full expansion. Instead of changing the whole network at once, we can test one corridor or one district, measure the results, and then expand carefully. Third, the slide mentions the stop-the-line philosophy. In Lean, this means giving the organization permission to stop and review a process when it is not working correctly. In public transport, this may mean reviewing non-needed runs when demand drops, rather than continuing automatically. Of course, this must be managed carefully. We must protect passenger access and service reliability, but flexibility is important. The goal is to make the service adaptive, not rigid. Slide 62. Link to other wastes. How overproduction creates secondary wastes. Overproduction rarely stays alone. It often creates other wastes. First, it can create waiting. If too many vehicles operate without good coordination, buses may wait at terminals, layovers may increase, and schedules may become unstable. Second, it can create motion. Extra vehicles and staff may need extra movement in depots, terminals, and route operations. Third, it can create inventory. If we plan too much service, we may also keep more vehicles, more spare parts, and more resources than needed. This is an important lean point. Wastes are connected. When we improve one waste, we may reduce several others at the same time. So, when we analyze overproduction, we should also ask, what secondary wastes does it create in our system? This helps us move from isolated problem solving to system thinking. Slide 63. Improvement actions. Short dash, mid dash, and long-term actions. This slide gives us 3 levels of improvement action. In the short term, we can adjust off-peak frequencies. This is often one of the quickest ways to reduce overproduction if the data supports it. In the midterm, we can pilot DRT or express routes. These options can help match different demand patterns more effectively. In the long term, we can develop integrated demand forecasting. This means using historical data, real-time data, land use changes, passenger behavior, and planning information together. A useful way to discuss these actions is the traffic light method. Green means easy and quick. Amber means medium difficulty. Red means long-term or strategic. Now, when you look at your own organization, which action would be green, which would be amber, and which would be red? This question helps us move from learning to action. Slide 64. Key takeaways. Main messages from day 3. Let us summarize the key messages from today. First, overproduction means cost without value. If service supply is higher than real passenger demand, we need to understand why. Second, we should match capacity to real demand. This does not mean cutting service without thinking. It means balancing accessibility, quality, reliability, and resource efficiency. Third, we should use data for decisions, not assumptions. Historical timetables, political pressure, and tradition may be part of the system, but they should not replace evidence. A simple way to remember today is cause, effect, countermeasure. The cause may be rigid planning or a lack of demand data. The effect may be empty kilometers, higher cost, emissions, and poorer resource use. The countermeasure is data-driven planning, flexible service design, and continuous review. If you remember only one sentence, remember this: more service is not always better service. Better matched service creates value. Slide 65, Session Wrap-Up and Preview. Close Day 3 and Preview Waiting Waste. We are now closing our Day 3 session on overproduction. Today we discussed how overproduction appears in public transport, why it happens, how it affects cost and sustainability, and how we can use data and lean thinking to prevent it. Before tomorrow, I would like you to observe one thing in your own system. Where do passengers or vehicles spend idle time? This will prepare us for the next topic, waiting waste. Waiting is closely connected to overproduction. Sometimes we operate too much service, but vehicles still wait. Sometimes we add more buses to cover delays, but this creates even more waste. Tomorrow we will discuss how waiting appears for passengers, vehicles, drivers, and organizations. Thank you for your participation today. I hope today's discussion helps you look at service supply and passenger demand with a new perspective. Slide 66, Questions? End of Day 3, Overproduction. Before we finish, let us take a few minutes for questions. You can ask about any part of today's session: the definition of overproduction, demand and supply balance, KPIs, DRT, ITS, environmental impact, or improvement actions. I would also like to ask you one reflection question. What is one place in your system where service supply may not match real demand? Please feel free to share one example, even if it is only an initial observation. These examples are useful because they connect the lean concept to real public transport operations. Slide 67. Thank you. Final closing slide for Day 3. Thank you very much for your time and active participation today. Today, we completed our first waste topic, overproduction. Please try to observe one example of waiting or idle time before our next session. This will help us make tomorrow's discussion more practical. If you have any questions after the session, you can contact me by email or through the communication channel of the program. Thank you again, and I look forward to seeing you tomorrow at 11 o'clock Turkey time.